All right, we are going to begin our discussion about forces by talking, as always, about Newton's first law. This is Newton's first law. An object in motion in a straight line will remain in motion in a straight line unless acted on by an outside force. Or we could read that as an object at rest will remain at rest unless acted on by an outside force. I think that's a very confusing way to say things, so I like to say it a little bit differently. And we're going to do it this way, this is how we say it in class, that means if the net force on an object is 0, the motion of the object will remain constant. So the big idea with the first law is that in the absence of forces, motion is constant. Let's write that down. In the absence of a net force, motion will not change. This means we have constant motion or we have constant velocity or we have a 0 acceleration. All of these things happen in the absence of a net force. Okay, so this, we'll talk about a couple examples later, but this means something very important about mass, and it's describing a very important quantity of mass, of matter, and that's inertia. Fancy definition for inertia is the tendency of matter to resist a change in motion. So, things do not like to change their motion. The bigger an object is, the harder it is to get it to move or to get it to accelerate. That's inertia. Now, the way we measure inertia and the way that physicists talk about inertia is that it's equal to mass. The more mass an object has, the more inertia that object has. The more mass an object has, the more it's going to want to continue in constant motion. The more mass an object has, the harder it's going to be to change the motion of that object. So, first law is very simple, but we're going to talk about a couple things. The first thing is net force. This isn't just one force, it's all the forces on an object added together. That little symbol is a sigma. It means sum. The sum of all my forces. All the forces added together. So let's say I have a 10 kilogram mass and it's going to be a box. And that 10 kilogram mass has a 10 Newton force acting this way, 100 Newton force acting down, 10 Newton force acting in this direction, and 100 Newton force acting up. There are forces acting on this object, but this force is pulling exactly hard as this force, so they cancel out. And this force is pulling exactly as hard as this force, so they cancel out. After I add all of these forces together, the net force on this object is equal to 0. And what we said with the first law, if the net force equals 0, there is no acceleration. And we have constant velocity. So, let's talk about forces. Okay, a force is the quantity that changes the motion of an object. Or, a better way to write that better way to say that is that net forces cause acceleration. If the net force on an object is 0, it has 0 acceleration, which means it'll continue going at a constant velocity. If, however, there is a net force, then we're going to have an acceleration. So, one little concept question, and we're done. A hockey puck is moving with a speed of 5 meters per second to the right. How much force is needed to continue that same motion? So, I want that 5 meters per second to continue without changing. So, to be clear, I want a constant speed of 5 meters per second. Oh, and let's go ahead and ignore friction. That's why we're on ice after all. In order to have a constant speed, the net force needs to be 0. So if we look at this hockey puck, it's got weight and the ice is pushing up on it, and it's moving forward at 5 meters per second. But there are no forces pulling back, so I don't need to do anything. The puck will continue at 5 meters per second forever until something else acts on it. The next video we have is going to talk about how forces accelerate objects.